Speaking again, can you hear me? That's how I always test myself on live streams because I also have a phone. And
Prova, prova. Benissimo, ciao a tutti, bentrovati, benvenuti a questo nuovo evento JUG Milano. Buon 2023 a tutti, so che siamo un po' lunghi nel mese, però è la prima occasione che ci vediamo di persona. Fa piacere vedere che c'è un folto pubblico, speriamo di vedervi spesso numerosi. Incontro JUG Milano numero 141, anche per gli amici che ci seguono da casa. Che dire, uno speaker di eccezione oggi, abbiamo Alina con noi che ci parlerà di Graal e soprattutto siamo in una nuova sede, questo JUG itinerante in cerca, diciamo, della propria meta. Oggi siamo fantasticamente ospitati da eDream e abbiamo qua con noi Luca che oggi ci presenta un minimo la location dove siamo per poi partire con l'evento.
Grazie.
Facciamo un applauso.
Benvenuti a tutti, il microfono è per YouTube, sentite? Allora, innanzitutto grazie di essere qua questa sera, non vi ruberò troppo tempo. Se avete bisogno di wifi c'è una connessione gratuita, la passo è Come Dream With Us, in camel case, già messo, così lo sanno tutti anche quelli online, con il punto esclamativo alla fine. Niente, spero che questa possa essere la sede del JUG. Abbiamo creato questi spazi non solo per i ragazzi che lavorano con noi, ma appunto per ospitare le community. Crediamo che supportare le community sia importante. Faremo anche altri eventi con altre community, abbiamo React.js Milano, il PUG e altri insomma, eventi che ci saranno. Prossima settimana abbiamo 2 eventi d'eccezione, uno con Sandro Mancuso, non so se lo conoscete, martedì 24, alle 6:30 più o meno, e il giorno dopo ci saranno altre 2 talk, una relativa a native, iOS, e un'altra relativa a machine learning, contextual multi-armed bandit, A/B testing, eccetera. Quindi chi è interessato può venire. Se siete interessati a saperne di più su eDreams, credo che lo conosciate, comunque trovate in giro qualche flyer. Basta, non vi ruberò più tempo. Thank you, Alina, to be here. And,
Thank you for switching to English.
I will translate you later, so nothing. Thank you.
Are we on? Can I speak? Yeah, excellent. Hi everyone, my name is Alina. Sorry, I don't speak any Italian, so you'll have to bear with me speaking English. And another disclaimer is that just like for me, this is the first meetup of the year after Christmas break. So be ready if there will be some, I don't know, mistakes, demos crashing, etc. So yeah, let's talk about cool native image apps with GraalVM. A few words about myself. This is my name, this is my Twitter handle in case you want to ask any question like in a private message. I'm a developer advocate for GraalVM at Oracle Labs, and Oracle Labs is this very cool R&D unit at Oracle. So we are doing a lot of research projects in things like programming languages, compilers, machine learning, security, etc. And GraalVM is probably one of our biggest projects that we've been working on for about 10 years before we released our first GA version. So yeah, that was one of our biggest projects perhaps. I also like open source and communities like this one a lot. And I'm Ukrainian, and the city that you see on slide, that is my beautiful hometown, Lviv. If you ever get a chance to visit one city in Lviv, I recommend that it is Lviv. It is beautiful, as you can tell, and I hope that we can all meet there at some point in the future. And let's talk about GraalVM. So how many of you have heard about GraalVM? Okay, pretty much everyone, good to know. And how many have tried building something with it? Fewer, but still plenty. That's a good sign for me. So a few quick words about it, because it's a huge project and there are so many things you can do with it that it gets sometimes confusing. So one thing GraalVM can do for you is run your Java applications faster on a JDK, so in the JIT mode. And in that scenario, we are using the same hotspot VM as you would get from the OpenJDK or whatever is your preferred build of JDK. And the only thing we are changing in this scenario is that we are replacing the highly optimizing top tier C2 compiler with our own GraalVM compiler. The rest stays the same. And in that case, the migration path is very easy because all your libraries, tools, IDs, etc. would work out of the box. The only thing that is changing is the compiler. So that is one thing you can do on GraalVM, and another one, which we will talk about today, is native image. So that's this ahead of time compilation mode that allows you to create native executables of your Java applications that start really fast, use way less memory, and are really great for, let's say, cloud deployments, serverless, microservice applications, but basically in any scenario where you care about startup or memory or packaging size. And the last but not least, GraalVM is also a polyglot VM, so it can run Java and traditional JVM languages, but other than that, it can also run JavaScript, Python, R, even LLVM languages such as C, C++, because we also have an LLVM runtime. And you can run one individual language out of this list on GraalVM, or you can kind of mix and match those languages together. And GraalVM will give you those interop capabilities out of the box, and it will also give you tooling and optimize performance of this whole application, even across the language boundaries. So that's an overview, and also GraalVM is an open source project. Our development is happening on GitHub. You can go and check it out. And also most of the project is written in Java. So if you are a Java developer, it should be fairly easy for you to figure out what is going on in there. It's a big project and we have multiple repos, but it's still a very interesting one to check out. So let's talk about native image. So that is this ahead of time compilation part of GraalVM that produces native executables. And what has happened in this scenario is that we will compile your Java code ahead of time rather than traditionally on the go, so in the JIT mode. And in this case, applications will start really fast and will use very little memory. What is also great about this is that all the major Java kind of microservice frameworks already picked up native image as their platform to build and run applications because of this. So it's very easy to build such applications that are using GraalVM with Micronaut, with Halidon, with Quarkus, with Spring Boot, or whatever is the framework of your choice. And the way this works inside, so because sometimes it's really interesting how do you even compile something so dynamic and something so dynamic that really needs this just-in-time compilation ahead of time. So how do you compile something like Java to a native executable ahead of time? So what we will do when we run the native image build of your application is the following. We will analyze your application, trying to find all the reachable code, so all the code that is actually needed for your application to run and execute whatever it needs to execute. And we will also initialize your application, so you can start your application with this pre-populated state. So those two parts are equally important because often people associate native image with only ahead of time compilation, and while that is important and a big part of native image, but also this kind of snapshotting application at the build time is another big part of the story because it allows you to start really fast with pre-populated heap. So that's the idea, and if we talk a bit more about the implementation of what is happening, so when you run the native image build, what it will do, it will start analyzing your application from its main entry point, and from there it will try to find all the reachable code so that only that code will end up in the final produced executable. And this is done to exactly build the most slim, lightweight version of your application, because whatever is not used will not end up in the executable, making it way smaller. Another part why it's so small is because it's all compiled ahead of time. So there is no this infrastructure for code execution and compilation in the executable. This all work is done at the image build step. So if you're working with native image, the way to think about it is that you are kind of splitting your application development cycle into build step and run step. And you're trying to move as many expensive operations, as many those really high load operations to the build step as possible, because many, probably most applications are started way more often than they are built. So you can build once and then you can start fast whatever many times you may need it. So to compare it to executing on the JVM, where those differences in startup are coming from, when you first execute your application on the JVM, there is a lot of work to be done for it to be running at all and running also in this warmed up state. So when you start executing your application, what happens, you would need time to load the JVM executable itself, start loading classes, interpreting, compiling, collecting profile information, and then when your application warms up, and I think you are familiar with this warm-up curve, so when it warms up, you finally will run with highly optimized compiled machine code. And in the AUT, so native image mode, since we did this all at the image build time, we already start with the compiled optimized code that is in our executable. And we also start with prepared heap that is coming from this snapshotting initializing application at the image build step. So that is the difference in terms of startup time. And the same basically applies to memory footprint, because when you're running on a JVM, you need to keep around memory for all this kind of code execution infrastructure, while on a native image, you only need memory for the executable itself and application data. So even if you compare those lists visually, you can see how much more efficient it is. And the also interesting part is when it comes to scaling your application. So if you look at your process on a JVM, if you need to scale it, you would need to scale all those, I don't know what color that is, I guess yellow, gray parts. So you would need to scale them per each process. While on native image, you would only need to scale basically the application payload part. And this is what it looks like for memory scalability if we compare JIT and native image mode. Okay, so that was a quick overview of native image, and now let's see if we can kind of power up our native image applications with some helpful things. The first thing I recommend for you to use if you want to start building your first native image application, or maybe you already built one but you are not aware of this, is that we have our official Gradle and Maven plugins from our team, and those will help you build, test, deploy your applications, so those are really helpful. And another thing they do is they will also enable JUnit support, so you can test your applications as you normally would do with JUnit. So you can just enable them by adding this plugin to your POM XML or your build Gradle file, and you can start using those plugins. And let me actually illustrate that thought by showing you a demo of how you would test such an application. Okay, so here we are. Let me just get in the right folder. Okay, so here's my Java application with tests, and this is my main application class, which isn't doing much. And also I have this calculator that is supposed to be doing, well, calculations. And to test that my app is working correctly and my calculator is doing a reasonable job, we also have this calculator test class. And that is doing some calculations that allows us to test this functionality. And if I look at my POM XML, I also have, where is it, my native Maven plugin. So that is from GraalVM Native Build Tools. So since I have all this, what I can do here is just do Maven p native test. And this will package the application and will run my test in the native image mode. So as you can see, under the hood, it's running this nice little command that helps us test the app, including JUnit and all the related things. And we are at the compilation step, so this should execute in a second. Okay, so it has built, and it showed me my test results as a part of that packaging cycle. So I can see that it ran all those tests. They are all successful. But also as part, let me get this higher. As part of that build output, it also showed me where it put those native executables, because those native tests are kind of native executables on their own. So I can go there and I can execute those just to show you that those are indeed native applications. How was it? Target native tests. So it's the same result, right? It was running as a native executable, so it's super fast, and it's showing the same output of running all of my test methods in the native mode. So that is that, and recently we also saw this announcement from JUnit that they added those two annotations specifically for native image, with which you can enable or specifically disable executing certain classes or methods with the GraalVM native image, so specifically in the native image mode. Okay, so this was nice, but what if you want to test something more extensive? So let's say you want to test against some dependencies such as database. So a good thing to do in this scenario would be to look if you're using some framework, and if that framework is offering some testing capabilities for you. And in this case, I will show you using Micronode test resources project. but basically similar support is coming from wherever framework is supporting native image. And for that, let me get to that app. Okay, it's here, and hopefully it will work because I changed this setup a bit on my way here. But let me show you though what it is doing. Hi. Okay, so this is an application that is intended to kind of manage a book list. So here we can put and read some books from MySQL database, and that's basically on the functionality. It also has functionality for book, author, etc. And it also has tests to validate that our application is working correctly. So at the very least, it can connect to MySQL and put and read some books from there. So let me test this one. Let me again pull this up. And one of the other things we are using here, so this Micronaut test resources feature of Micronaut is using as one option, because there are others, it's also using test containers. How many of you know test containers? Okay, I'm always asking this because I like the test containers project a lot, and I'm always happy to see that people in the room like it too. So if you pay attention to this output, this is test containers spinning up a MySQL container for me so I can test against it. And now we see that our test ran. So the MySQL container that we needed to test our application was existing, and we tested against it successfully. And also we had one minor greeter test that is basically just saying hello, and that one ran successfully too. So for testing against some external dependencies, I think test containers is a good option, but also as another suggestion, please look in whatever is your framework offering you. This could be another good way to test native image applications. And to give proper credit, this project I think was developed, but also this demo that I was showing was created by my colleague Cedric Champeau, so huge thanks to him for this. Okay, another thing is GraalVM and reflection. So if you will be working with native image, this is a thing you need to know. And I'm curious, how many of you have heard that GraalVM doesn't support reflection? You can raise hands, it's okay. Because like, people are raising, but like, you know, shyly. Some people think this way, and this is not true. GraalVM does support reflection, but yeah, one thing is that you can always run things on GraalVM as a JVM, so in that mode, everything works out of the box perfectly fine. Another thing is that you can also work with reflection in the native image mode, but it does indeed require some configuration for it to be working. Still, there are some nice things even around that. So one thing is that native image will try on its own detect some reflective calls and figure out this configuration for you. So sometimes, in some cases, this would not even be needed from your side to configure it. Native image will figure it out on its own. So that is one thing how this can happen. Another thing is that ideally this reflection configuration would be coming from the library or framework that you are using. So that would be very helpful, and that is probably a preferred scenario. Another thing is that GraalVM Native Image comes with this tracing agent that can observe your application behavior on the JVM and kind of record this configuration automatically for you, so you don't need to do this manually. And then as the last resort, you can always create this configuration manually. We have kind of templates and guidelines for that, but that should be probably your last resort. So ideally, it will be coming from your library or framework. It will be coming from tracing agent, and then in the very last, you can configure it manually. So the tracing agent that we have here, it's very helpful to figure out this configuration, but still there are things to know. A, you need to apply relevant workloads, so your application will execute exactly the code path that will be included in native image. And B, we always recommend that please use tracing agent, but also review the configuration that it provided to make sure that it's complete, so do not rely on it 100%, just check it out just in case. And let me show you how that works in practice. So for that, I have another demo here, and what is happening here, if I can just open it. So I have this application so this is my application class that is trying to read this message field from the message class over here. And you can tell that it's doing so in a maybe slightly less obvious way. And the reason why this is written this way is to try and confuse or outsmart native image, because if this was written in a more obvious, predictable way, native image could figure it out. But for the purposes of the demo, so we can show configuration, this is written in a slightly less obvious way. Let me check a few more things with this demo. So here's my POM XML, and where is my native agent? So it's here. Let me set this to false. So I will not be using our native image agent. That is one thing. And another, I have a folder where I would normally keep my configuration for native image. So each of these files represents config for the category like reflection, proxies, resources, etc. So let me look at my reflect config. It's empty, all good. So let me try and build this app. Okay, this all should be good. And I think I'll skip tests so it doesn't complain to me, but it actually builds and we see what happens then. Okay, so it's a normal build. It will try to build my application as a native executable, and then we will see if it can access that message field. And just to go back to our code, okay, so our build succeeded, and the app is called example app. So let's build this. And it says reflection not working, so that is our exception message from over here. Luckily, this one is not so hard to fix as some issues can be. So let me go back here. Let me use the agent again. And as I do it, another thing that I have here is this script. Where is it? Agent run. So this will run the agent on the JVM. So we will not be building the native part. So it will just run the agent on the JVM. So we can collect this configuration, and we will see if this helps. So it will execute application, and as it executes, it will figure out that it's trying to read that field and provide configuration for it. So let's run this. And it's very quick because it's on the JVM. So if I go back to my reflect config, I see, if you recall before, it was empty. So now it has this config part for the reflection. Of course, in this case, it's smaller because application itself is small. So something like this, you can totally, provide manually yourself. But for bigger applications where there's a lot of code and a lot of those dynamic things happening, this tracing agent could be really helpful, so you don't need to provide all those things manually. So let's build this again. Did we enable the agent though? I think we did. Yeah, and now I think it's picking up configuration. So the agent is on and it's trying to find configuration in all those directories, so native image can build the image aware of this configuration. Okay, so it's up. Let's test again. And now it says hello native, and that is our message that is in this message class. So now it can access it because it has configuration for it. Okay, do we have any questions yet? Okay, I think looking good. Let's move on then. Okay.
Also, So one from our friends connected, I think is also a good time also to do this one. Daniele has this question. Earlier when you presented about the differences between say JIT and GraalVM, so as from some perspective they can be interchangeable at times. Is there any plan to eventually just have GraalVM replacing the JDK? I think that actually Daniele had one specific point which is of interest, that sort of like the compiler, if I'm not wrong, of JDK is written in C, while for GraalVM is written in Java, so that as we are all Java programmer, developing GraalVM itself with Java will be easier. Do you have anything to say about this type of question?
Yeah, thanks for that. So indeed, GraalVM, the compiler, is written in Java. So that was the part that I mentioned when most of the repo is in Java, right? It's a very interesting thing that you can write even such pretty low-level things as a compilers in Java itself. And indeed, it's probably more maintainable and manageable in a way that it's written in Java. Unlike C, I'm not a compiler engineer myself, but compiler engineers say that writing a compiler in Java, it's a very good idea because you get to use all the proper tooling, and itself, the project is more maintainable. Now, for GraalVM versus JDK, it's not exactly the, I don't know, contradiction that I see myself, because those projects kind of benefit each other. So for one, you can use GraalVM as a full-blown JDK, so you can just get other builds and run your Java application just by basically using a different Java distribution, which is GraalVM. So they're not conflicting in a way. And indeed, even more than that, maybe you saw this announcement recently from Java 1 that parts of the GraalVM project will be contributed to OpenJDK. So they're becoming even more and more close. So I don't think there is any conflict there. So you can just easily use either. There is no conflict, no migration issues, and they're becoming even closer now. So I think we have more exciting news coming in the future. I hope that answered this question. Thank you. Okay, let's go back then. So here we are configuring our reflection in our own app. But what if we are using some third-party libraries, and sometimes it's harder to figure out what exactly is happening in that library because you might be not aware of the library fully or how it works completely. So that might be harder to configure, and for that exactly we build this GraalVM reachability metadata. Let me just close, because apparently I have a million windows open. So for that, so it's easier for you to work with various libraries and avoid having to configure this metadata yourself. What you can do is, why isn't this working? Yeah, we have the centralized repo on GitHub where our team, so the GraalVM team, but also our community is contributing and sharing configuration for some popular libraries and technologies. So it's easier for you to reuse the configuration that somebody already has created. So basically, you don't need to recreate the same configuration and do the same job. And if you look at this, I'm actually in the metadata folder. So already we have here some things like, I think I saw Hazelcast somewhere there. We have configuration for H2, for things like, where was it? I think MySQL, Postgres, and other kinds of things. So the way this works is that if you are using our plugins, so Maven or Gradle plugins from GraalVM Native Build Tools, you can explicitly enable access to this repo. And if your app is using one of those libraries, the native build tools would pull in this configuration from GitHub, so you wouldn't need to recreate this configuration manually. And once again, let me show this to you as an example. So another app that we have here, I'm just getting lost in those folders. Here it is. So this app is trying to use H2 to put and then read some customer list to basically H2. And that is basically all of the application code, but since it's working with H2, you would normally need to provide configuration for the application to work properly in the native image mode. So let's see if we can do this pretty much automatically. So one thing I have here in my POM.xml is that I have this specific configuration part that tells that, hey, there is this metadata repository and I'm enabling access to it. But let's say I don't know about this, so this part of my build file doesn't exist. So let me save this, and let me see if this application would build like this. Okay, so I think this one is taking a bit longer to compile for whatever reason, I don't know. So maybe you have some more questions or comments at this time. Go ahead. Or do you need to do a mic thing?
Approfittiamo per gli amici a casa. La domanda è corta.
How works the garbage collector in GraalVM? I used to manage the garbage collector to set parameter in JVM, use G1, ZGC. In GraalVM,
if you don't mind, I will answer that in maybe like 10 minutes because I have a slide just about that. So I can illustrate that thought with a slide. Okay, so I will get back to that, I will not forget, but let me see how this app is working. So our native image build finished, and our app is here called H2 demo. So let's see how that one is working. And it crashes, and who doesn't love it when live demos crash, right? So what it says specifically is that it cannot figure out how to work with H2. Luckily, this one is easier to fix. So I'm just going back to my build file, and I'm putting this back on, saving, and let's build again. And it's interesting how I don't know if you paid attention before, but before this very command to execute native image build was shorter. Now it's significantly longer, and also if you look super close to it, we can see that we are passing some parameters around H2, and we are pulling configuration to it from this repo, and there is even, I think, a commit where this specific configuration was committed for H2 to this repo. So now our app on native image build actually picked up this configuration, and hopefully it will work now after this build completes. Okay, it's on, so let's run it again. So now it runs, so it can successfully put and then read those customers from the database. And I think it's really cool that I didn't need to specify any H2 specific configuration. I just enabled access to the repo, and then it pulled this configuration for me, so it wasn't anything manually produced by me. Okay, so this is config, and that was it. Okay, and let's talk a bit about performance. When it comes to AOT compiled code, sometimes people have this misconception that it will never execute at the speed of JIT. And there are some reasons to think so, because obviously JIT executes code dynamically, and it has runtime information available, and it has great GCs, so it's really hard to beat JIT, and specifically the Java JIT. That is true. But also, IoT has some other advantages, and one is that we have this build step, which means that we can execute all those operations at the build step, but also it means that we can apply more aggressive optimizations because we have time and resources for it, unlike on the JIT when we need to execute our application as soon as possible. And also the closed world assumption that is used when we compile our Java application ahead of time to native image, it also enables some additional optimizations because we know that there is nothing happening at the image execution time. So we can apply, again, aggressive optimizations because all information is available to us at the image build time. But there is also a reasonable question, so what about profiles? Because when we're executing code on the JVM, we have profile information available, so we can adapt on the go to how our application is performing and optimize specifically for those scenarios. And this is where something called profile guide optimizations come into place. So to try and handle this, we are trying to combine the best of both worlds, so combine benefits of the JIT with the ahead of time code execution. And the way we are doing so with profile guided optimizations is the following. So if you can build an instrumented binary and then again run relevant workloads with your application, we would observe your application behavior, collect this profile information, and then if we feed it to native image at the build time, it can build a native executable aware of how your application will perform at the image runtime, and this way it can achieve really good peak performance because we are optimizing specifically for your application behavior and what it does at runtime. And to answer the GC's question, so this is in the native image mode, but I will have something to say about JIT mode later on as well. So these are the options available in native image. There is a serial GC, which was the first GC added to native image, and it's available basically by default. And there is a G1 GC, which is though available in GraalVM Enterprise, but it's available for things like development, testing, evaluation, so don't let that scare you. And then in case you don't need to do basically any GCs at all, there is an Epsilon GC available too. So these are options available at the moment in native image. And in terms of memory management, so that's not exactly a GC question, but just to answer, you can also configure native images, memory parameters as you would on a JVM. So most of the commands you would use on a JVM would work on native image as well. So you can limit, let's say, heap memory used by a native image. All those things would work as well. And in terms of how would you work with native images and what else you can do with them, is that you can also monitor performance of native image applications using JFR. For that, you would just need to build native executable by passing this one more flag, which is enable monitoring equals JFR. And then you can start your app, record a snapshot, and you would, let's say, with tools like Visual VM. That is one thing in terms of monitoring, and another thing that is in the works is JMX support, and that should be coming in the next GraalVM feature release, which will be in March. And both those things, JFR and JMX support, we see a lot of contributions from Red Hat, and I assume there are some Red Hat people in the room, so thanks for this. And another thing you can do is native image. So this is all about how you can optimize native images even more. So in case you are concerned with the packaging size, so how big the native executable itself is, you can use something called UPX to compress it even further. So one example we can see here is compressing a Spring Boot app and going down from 66 megabytes to just 17. So if for whatever reason, maybe you're running in resource-constrained environments, this is important for you, you can use UPX. I do need to say, though, if in case you will be using more aggressive UPX algorithms, this can have an impact at runtime, so be aware of that. But as many things, this is a trade-off. So if you need to compress your executable, UPX is the way to go. And in terms of deployments, you can also build so-called mostly static native images, so linked against everything except for muscle libc, or completely static native images, so you can deploy them on distroless container images, for example. And another interesting angle of native image that I think is often overlooked and that is not fair is the reduced attack surface. So because the compilation is happening at the image build time, no new code can be executed at the image runtime. And this is often overlooked, or some might say that this is a disadvantage of native image because you cannot execute new code when you run the application. But I think it's just a different, I don't know, design choice and a different way to look at things. And it has the security benefit that no unknown code will be executed when you actually run your application. Another interesting aspect of security in native image is that only the code paths that are actually reachable will be included in the native image. So if there is some part of your application that is actually never executed, or if you are pulling in some dependency that you are not so sure about, what native image will do, it will only include the code that you actually need for your application to do whatever it has to do, and all the rest will be eliminated. So if something is not used, it will not be included in the file. And that is another thing how it can help from the security perspective. Also, things like reflection and deserialization are by default disabled, and as you see, you need to enable them by providing configuration, which again can be helpful. And some other attack vectors that are coming specifically from the just-in-time compilation, such as specifically targeting a compiler in terms of security. Those will also not be possible at all in native image because there is no JIT code execution in native image at all. So that is another interesting thing to kind of remember about native image. And a few things about what is new in GraalVM. So this was announced some time ago, is that you can also debug native images in IntelliJ IDEA. So I believe this is still in preview, so you would need some kind of experimental build for that. But I think this is great news and very exciting, and we are all waiting for this to happen. And we talked a bit about new monitoring features in native image. So you can now use this enable monitoring flag to monitor the application's behavior even if they are native executables. And we also recently, I think in the past release, added support for JVM style in native image as well. And as of last release, we also have JDK 19 builds available, because for the longest time we had first JDK 8 builds, then 11 and 17, and since recently we also added JDK 19, which is very exciting news because you get to use all the features that came in between 17 and 19 now with GraalVM as well. And let me show you one demo. Let me first credit the author. I have this table here. So this will be a game of life demo, which I think Mario likes in particular. And I want to give the credit to the author of the original Java implementation. And we kind of re-implemented it in the native image mode too. And I have it here, and I can just run it like this. So this is a highly kind of computation intensive application. So each cell, to figure out whether it's alive or dead, needs to talk to its neighbors to figure out its state, and it's doing those through channels. And there is a lot of such communication happening at the same time, and also those generations change very fast, multiple times per second. And this is using virtual threads from the project Loom, which you can now use with the GraalVM, including the native mode. One thing to be aware of, so since this is a preview feature, we also now have a concept of preview features in GraalVM as well. So if you want to use something like this yourself, you would need to pass this additional enable preview parameter through command line or build file. But now you can use virtual threads with GraalVM, and specifically in the native mode as well. And another thing that I wanted to show you is also related to JDK 19, if I can just find this folder. So there is also this kind of quick and simple web server developed, I think available since Java 18, if I'm not mistaken. And what we did is obviously we compiled it to native as well, because it's basically a Java app. So now it starts super fast. You can barely notice this startup time at all. And if I go and open it somewhere, oh, I think I have it open. So it's a normal web server which works as expected, but now it's also compiled to native, so it's even faster. So okay, it works. Let me just update the page. It does work. But another cool thing I can do is, since we recently enabled this JVM start support in native image, I can also observe my application behavior. Okay, did we restart it or not? We did. Let me go back here, and I think this is our new process. Yeah, simple server, this is it. So it's using quite a bit of memory, as you can tell, right? So I think below 9 megabytes. And it's working, but let's make things more fun, and let's apply some more load to it. And for that, I will use this tool called Hey, and I will send 1,000 requests to our server. So again, super fast. You can barely notice it at all, but it shows us response times, and they're looking quite good. And if you go back to Visual VM, okay, not sure why this went down. Maybe there was some weird GC happening, but you can see that we are still below 8 megs, and we are successfully serving those extra requests. And this application, even in native mode and being so tiny, it's perfectly capable of serving such requests. Okay, let's go back. And also, if you're curious what's happening in GitHub, in GraalVM next, we have this public roadmap on GitHub, so you can see what's coming up in our next releases, what we are working on, what the community is working on. So I think this is very interesting to look at. And going back to the GC question, so we are also planning to add support for ZGC. This is in GraalVM JIT at the moment, so only available in GraalVM JIT, because typically all things would work on GraalVM JIT, but specifically GCs are a bit trickier because there has to be some kind of interaction happening between the compiler and the GC. So typically we support the base standard GC in whatever JDK version we are building upon, but something additional like ZGC, that takes an effort. So now we added this in the JIT mode as well. And in terms of native image, one of the things we will work on next is we will keep working with the compatibility and making sure you can use small libraries with GraalVM Native Image. We also work with all the frameworks team to make sure that you can use a native image and all the latest features in whatever framework you are using. And we are planning to extend and work with IDE vendors to extend IDE support as native image and keep improving things like performance and GC even further. And very briefly, I want to mention a few things about polyglot capabilities of GraalVM because I think this is super interesting. So those are all the languages that you can use on GraalVM, and below are the platforms in which you can use it. And those are kind of official languages implemented by our team, but also on GitHub we have this list of kind of community language implementations. So this is something people implemented on GraalVM themselves. And you can see some fun languages in there, like, let's say, I don't know, brainfuck JVM, that's probably my favorite. But yeah, quite a few languages that are implemented on top of GraalVM. And just to give you an idea of how much effort it takes, is that we saw on social media somebody sharing that they implemented PHP on GraalVM, because we also give this like language implementation API, so you can pretty much write an interpreter for your language in Java, and then we will give the rest of infrastructure to you. So somebody, a student, implemented PHP on GraalVM in something like 6 months, along with the rest of his work. So I think that gives you an idea of how accessible and like time it takes to implement a new language on GraalVM. And the benefits of implementing languages in GraalVM is that not only will it give you this language implementation API and platform, but also it will optimize and give you tooling and also take care of the security of your whole application. And basic kind of anatomy of such basic application that is polyglot is the following. So here we have our main application that is in Java, but let's say we want to use some cool Python code from it. So for that, we will create a context, which is basically a language execution, I don't know, container environment. And we will say that we want to use Python and provide this Python code. And that is basically how you would write such polyglot application. And probably one of the challenges with writing polyglot programs and why people write them not so often is the tooling. So to do such polyglot applications, tooling becomes even more important. So luckily, we give you a lot of tooling as well, specifically that works for such polyglot programs. Let me see if I can super quickly find this cool flame graph. Oh, okay, opt carrots. So one of such things is that we also have a CPU sampler that works for all GraalVM languages, and it also gives you those very cool flame graphs that I like a lot. So what we see here is an opt caret Ruby application, and basically here we see how much CPU time is spent in each method, and we can dive in here. So let's say go here and see the details. Or if we go back, and I know we want to find something, let's say this loop, it's also kind of interactive and searchable, and you can search for things here. Or if you prefer, you can just look at the normal histogram. So this is working for all GraalVM languages. Okay, so that is that. And another cool example of GraalVM polyglot, which I like a lot, is that GraalVM is kind of embedded in Oracle database. And this is using all of our components at once. So we basically embedded GraalVM's JavaScript runtime, so you can execute JavaScript code directly in Oracle database. And we used specifically native image to perform that embedding, where we're using database as our platform, so basically as our operating system. And then we embed parts of GraalVM, such as this JavaScript runtime, in it as well. And another interesting example that I wanted to mention about polyglot is we recently saw this blog post from those Aryan folks who wanted to migrate parts of their C, C++ payment applications to Java. And they were considering different options like rewriting the whole applications in Java, or using I don't know, some other alternatives, but the way they ended up doing this in the end is that GraalVM also has this LVM runtime called Solong, and it also gives you this managed execution mode. So you can write that existing, run that existing C, C++ code on the JVM, and you do so in a managed environment. Okay, I have a feeling that I'm getting out of time. How are you doing on the time? Okay. Okay, so I can talk as long as I want. Okay. Okay, but this is pretty much the end of the slides anyway. So to get started with GraalVM, two things. We have this one kind of line download thing for GraalVM. So you can just run this command and get the latest release of GraalVM. Or you can use SDK man, which we all know and love, to also get the latest release of GraalVM. In a nutshell, what GraalVM gives you is more performance in the JIT mode with the new compiler, or fast startup and low memory footprint with native image, or polyglot capabilities in one VM. That is it. That is my name, and that is my Twitter handle if you want to ask more questions. And thank you all. Do we have any more questions?
A question that a bit surprised me about performance. You know, I have that game of life made with Loom, and thanks to your help, I also did the native version of it and tried to compare the performance. And yeah, the JDK version was like 10 or 15% faster, which is reasonable, I think.
That's okay, thank you.
Yes, but what surprised me is that yeah, of course, with the JDK, I had a quite relevant warm-up phase, but still I observed a small warm-up also for the native image, which surprised me, meaning that I have a transitory phase where the native image was slower than and I couldn't explain this to myself, because I think that everything is done at compile time. Every optimization is done ahead of time. So I don't have an explanation for this.
Yeah,
yes.
so it's kind of getting into the compiler engineering part and like operating system stuff. But the way I understand it, and I was explaining this, is that still like don't quote me on this, but as I understand, native applications still also get this warm up curve on the like OS level. So they do warm up on the like operating system level. So if you, let's say, start a native application, not GraalVM, but like any native application subsequent times, they do warm up a bit on the like operating system level. So that could be that difference. I did not try it myself, so this is not like something I can confirm, but I talked to our guys about this because I observed this on like another native application. This is what they said, that there is still some kind of warm up curve for like all native applications, not just GraalVM specific.
Okay, thanks.
Thank you. I had the same question, really. And but what about at the end? At the end, the native image get worse. It's inexplicable for me. I don't understand why. Yeah, they get worse. Can we take the?
You mean the
slide,
native
please?
one?
Yeah, the native one. Yeah.
The game of life.
No, I am talking about the slide where you show the performance of the native optimized.
Yeah. Let me find it. You mean this
that one? If you see at the end of the native optimized image, it should stay still until the end, but at the end it get a little bit worse.
Again, so it's a matter of measurements, and a lot of things can be happening on your machine, even though I think this was taken in the like proper benchmarking setup, but still there are other things that can be in the play. So we expect native image performance to be more or less still over time. So that is another way to look at it, and it could be beneficial in a way that if you want predictable performance, so if you don't need to warm up or you don't need to go down, but you want it to be more or less stable, then it's another way where native image is helpful. Here, I don't think it's a dramatic change.
It's not, but it's strange.
Could be this one workload, could be benchmarking setup, but also I think some fluctuations, like here, they're not so huge. I think this is more or less natural and expected. I don't expect this to be a huge deal.
Could be something related with a garbage collector, for instance.
I don't think this would be a garbage collector in this case, but honestly, I would need to look back into this workload and how this was taken. But to me personally, like from my perspective, some minor fluctuations are okay. So if you saw the curve going like extremely down, then I will be worried. But some minor things, from my personal perspective, should be okay.
Okay, thank you.
Thank you.
And have you ever experienced a different behavior of the same application running in GraalVM and between GraalVM and JVM?
So between GraalVM and JVM, but do you mean GraalVM native or GraalVM JIT?
Native image.
Native. So in terms of behavior, they should be the same, because I think that's the very least you expect from your I don't know, application execution, that it behaves as expected. So if you ever see that it doesn't, please report it to us, but in general it should never be the case. Plus another thing that I didn't mention, and I think it's also interesting, is that we are using the same compiler. So those are not different compilers. That is the same GraalVM compiler, only it can work in JIT or AUT modes. So it's the same compiler, so the result should be the same. It's just doing those things differently, either on JIT or ahead of time. But the application behavior should be the same, so if you experience some differences, that would be weird. Now, another thing, if you're trying to do some, I don't know, like random stuff, that of course, because GraalVM is doing, native image specifically, is doing all those things at build time, so you need to take that into consideration, and such things would need to be initialized at runtime. But in general, the application behavior should be the same, so we do not expect any deviations. If you ever see something like that, please report to us, but should not be the case.
Okay. So
Thank you.
I can debug the application in JVM mode and run in native mode.
Sorry?
I ask just to understand if I need to debug my application in native mode, because maybe it maybe has a different behavior. So I think it's not.
Yeah, I mean, all things should be the same. The only thing you should be aware of is all those more dynamic features of Java, such as reflection, proxies, resources, etc. So those would need to be configured. But other than that, they should behave the exact same way in JIT and in native image mode.
Thank you.
Thank you. Any more questions, or maybe in chat?
Boop. Thank you for your talk.
Thank
It's
you.
been enlightening. Yeah, I have a question for you. I kinda use a lot native image for personal use, and since a few months ago I use it at work too. But the thing is that, let me say that I didn't trust it enough to develop application like client-side application or application that may affect somehow the user experience if they have some kind of strange behavior. And so we basically relegated native image to just compile like command line tools or tooling in general for our team. And my question is, since the main reason I had this fear is that, to the best of my understanding, in order to be 100% sure that the reflect configuration of your the reflect configuration that the native agent produces once running your application, in order to be like 100% complete, you have kind of to pass every input that's possible, every value in the spectrum of the inputs you can send to your application via, I don't know, the command line sockets, TCP somehow. Well, my question is it correct? Is there some way I can be like 100% sure that my application won't blown up due to misconfigure reflection if compared to the JDK version one?
Yeah, I can see how
JVM,
client applications are a bit more challenging than server-side application. The question is, are you using any framework for that?
No, not really, but I may be using some kind of weird libraries from that I'm not the complete control of. So they're kind of black boxes, and I don't really know if they do some reflection of other odd things.
Because, I mean, ideally, again, that configuration, if you were using some framework that was compatible with native image, something like that will be implemented on their side, right? So that will be an easy solution to your challenge.
Yeah, yeah.
Now
It's in the case of more, esoteric libraries or not so well-known libraries.
To be honest, I'm no expert on client applications. I would maybe look into Gluon if that tells you much, because they specifically work with native image, and I think they have some way of handling that. So if you could look into Gluon, they specifically work with client applications and compatible.
What? Sorry?
Gluon, let me see.
Gluon. Yeah, I know them.
Yeah.
Okay, thank you.
So those, I think, would help you, because they specifically use native image to compile ahead of time applications, and they use those on clients. So I think that would be one good option. Otherwise, the thing with native image is that if something isn't configured, and again, like native image will try and try to figure out some things for you, but there's only as much as it can do at the image build time if this thing is not available. So yeah, I think my answer here will be that ideally you would use some framework that is compatible with native image. Otherwise, you would need to go and try, but if some configuration is missing, that might be an issue.
Okay, thank you.
Thank you.
Another question about the performance guided optimization scenario. You mentioned about the possibility to run different workloads that produce different profiles, but I mean, the different workload can be very different. One of the things that the JIT does is they optimize and re-optimize based on the load. So is there some smart way that means like I try to compile different scenario and switch based on that, so a sort of the optimization, or essentially try to do like, okay, an average?
I mean, one question is how good and complete are your tests? But also, yeah, this is a bit of, again, where native image needs a bit of your help, because if your workloads that you're running are not complete, then there is no magic way to...
Complete is like that. Maybe over the day, I have a very different behavior, like brand prediction is different. So the JIT usually is able to say like, okay, I realize that now the scenario is different and they optimize. So they're all valid workload. They are just different in the same application.
So if you want to have good profiles and if you want the best performance, then you would need to run as many and as relevant workloads as possible. So there is a way for you to run like a lot of them, or like a major amount of them. That will be preferred.
If essentially those let's say different workloads produce a different performance guided information, because essentially they are matching like, okay, let's do a very basic example, branch prediction. The first workload is hitting the first condition. The second workload is hitting the second one. And both are valid. It's just that I don't know at the moment essentially which one is the one that I'm running. So I'm guessing how it could let's say use different. I'm a bit surprised that it's able to manage different profiled guided optimization profiles. Like, okay, if the input that I'm providing, it's different, I produce a different performance guided optimization information, and how they can be mixed in the same native.
I mean,
yeah, but in the slides it was saying like I have multiple of them and I provide them. That's weird.
Okay, so this is getting into implementation details, but yeah, I think if you can provide a lot of them, that will be helpful in terms of branch prediction. So I looked into this for GraalVM JIT. So on JIT is obviously easier because we kind of keep like a table of all those branches and like probability for each on JIT. But on native image, to be honest, I wouldn't know how if we have the same kind of table on native image. So yeah, typically the recommendation is apply as good and as many relevant workloads as you can to give the best profiles. And that's because, again, it's a trade-off, right? So if you definitely need to have this profile information constantly updated and have this chance to de-optimize and compile again, then probably GraalVM JIT is your best bet, because maybe that is just not the best scenario for native image. But if you can have a way to provide those at build time, then native image would be a valid option as well.
Yeah, I was guessing if there was something like in the middle that's like, okay, in reality, in the binary that I'm producing, I preserve both code, and I have, let's say, directly the native saying like, okay, I realize that I am in a different scenario and I use a different, let's say, code path. Of course, the binary is becoming bigger, so I was guessing if this is a sort of mechanism that exists.
To be honest, I have no idea how that profile information is stored, but from my perspective, that should be possible to store like multiple profile information and like, I don't know, merge them or whatever. But that's just me guessing, to be honest, so I wouldn't do that.
Thank you.
Yeah.
I have two questions.
Mhm.
One is related G1. In the slide there was mentioned that is part of Graal Enterprise.
Yep.
There is any plan to make it part of the community edition or not?
I mean, not that I'm aware of, but over the time we added to Community Edition quite a few features that were previously only available in Enterprise. So I'm not saying never, I'm just not aware of such immediate plans.
Okay. And the other one is related to JFR.
Mhm.
I noticed that, was mentioned my company, Red Hat, about JFR. And I'm kind of surprised because, not surprised that my company
I was
contributed-
thinking you were surprised that
No, no.
Red Hat is contributing.
No, not surprised that the company contributes to open source, but actually that, observability tools, usually for any could be an ancient or a new technology tends to be, the key aspect to understand if it works. Why only now? JFR are Duke for observability tools. I'm just surprised that wasn't there from the beginning, if you know. So just curious.
Yeah, so it's not only now. The reason I have this slide is because I think this is often overlooked. So I think JFR support was available since, I don't know, like at least a year ago, I would say. So for a while, I just always mention this because I think for people, it's not always obvious that this exists, even though we have this in docs, etc. But I want to mention this because if you will be working with native image in production, you would need such tools, right? So that's the reason I'm bringing this up. And it's been around, like, I'm not even sure, for a year, maybe even longer, like a year and a half. So for a while, but also I guess maybe it just wasn't trivial to implement in native image, or maybe there were some other considerations. But yeah, it's been around for a while, and we keep building it out.
Okay, so it's not a kind of feature that hasn't been ported from the enterprise thing. Was actually missing even in the enterprise stuff.
It might have been in enterprise. I wouldn't recall it now, to be honest.
Okay. Okay, it's done.
Yeah, but from what I remember, it's around for sure for like 1.5 years, I think. So, and I think our like first GA release was like 3 years ago. So not immediately, but quite soon, I would say. So.
Okay, thanks.
So a couple of questions from the chat, maybe?
It's a lot of questions.
Yes. So one actually is from Angelo. Angelo is asking, Oracle announced that the most applicable parts of the GraalVM Native Image implementation will be contributed to OpenJDK, as we were mentioning earlier. Are there some known parts which will be not at this time?
So for that, the best thing would be if you went and checked the announcement on our website. But from what I can tell, I think all those other languages, such as our JavaScript implementation, Python implementation, etc., those are not going into OpenJDK because those are basically other languages, right? So that was regarding the compiler and native image.
All right. So then also myself and I think it was Daniele, we were discussing about something. Maybe here is a part, my question, trying to learn something new. So I've always seen, beyond native image, so just speaking about GraalVM, I've always seen it as a platform from where I would have my Java, would be coding my Java application still with a closed word assumption, not necessarily doing native image, but let's say trying to have that mindset. With the things that we've been discussing today, could we say that actually tomorrow I should just replace my JDK with GraalVM and expect it to be running most of the time?
Oh my god, please don't say like replace JDK with GraalVM because GraalVM is also a JDK.
Right. But let's say on my Symlink on my laptop, would you advise somebody like me that, let's say, by default I would have the Symlink of the Java C to, let's say, an OpenJDK distribution? Could I sort of like in normal circumstances just Symlink to a GraalVM platform?
So again, JIT and native. So in the JIT mode, you can totally replace OpenJDK or whatever build you have with GraalVM build, and all the things would work as expected. In native image, though, I think it depends on what you are trying to accomplish. So I think it's still a valid scenario where you would run on GraalVM JIT, and there are quite a few applications that would benefit in that scenario as well. So our typical recommendation is GraalVM gives you both. So just take it, run on JVM, run on native image, because each workload is different and you might have different priorities, and compare which one works better for your application. Because let's say startup time is important, so that's why people choose native image often. But what we see happening again often is that memory could be even more important than startup, because let's say you're in the cloud and you pay based on memory as well. So we see this happening a lot, that for some users, for some teams, for some workloads, memory is even more relevant concern than a startup time, because you start your application, but then as you keep running it, memory might be a more relevant metric. So long story short, get both, run application on both, see whatever works best for you and what you are trying to accomplish.
Right. Then I have actually another question that actually speaking back on the question earlier about reflection. It's like I am responsible for a module that supplies just a JDK jar for other people to use it in native image. And basically what I do as part of that is that I put a reflect config JSON inside of that. So I would assume that sort of like what I try to do is that I have my own ways of figuring out without necessarily the agent, so without having to try the payload. I just know beforehand, oh, all the classes that has this this interface should be there, and then I make it there and I ship it. I'm wondering more on the consuming point of view. So let's say that I am a developer having all this jar with those reflect config. Would there be a situation where that so many reflect config would actually cause some performance regression or some other type of regression because there are just so many entries in there?
Well, again, it depends how big your application is and how big the configuration is. So it could maybe have some impact, but then again, configuration itself is not that big. It's maybe more of the consideration is how big your application will become if you want to include absolutely everything, right? Yeah. So I had that question once, so what if I need like absolutely everything at runtime? So I want to register every single class, method, etc. for native image. Is that possible? I mean, technically it is, but then you might as well run on JIT if you actually need like absolutely everything, right? So that could be a consideration. Another thing about reflection is that I don't know if that is asking from a library perspective or just distributing jar to users, but if that is from a library perspective, a good thing to do would be to, like, if you're shipping config, that's already excellent and that's great news and we are very grateful. But another thing you can consider is shipping this config to this metadata repo where it can be automatically picked up by other build files, and it's like a centralized space where if you're using native build tools, it will be picked up automatically. So shipping with the library is great, but another thing you can do is also contribute there, and then it will be a bit easier maybe for users to discover it.
Okay, makes sense. Other questions? Yes.
Last one, just about the libraries. What about, I have many applications that would be great if I compile in native mode, but they have a lot of a lot of different libraries, a lot of dependencies, where they were written long ago, and I'm not sure that such libraries were
compatible.
What can I do? Just try an error and try to find out if I find out, is there some kind of best practice to approach this kind of problem?
It's interesting that you're asking that, because we are working on that, something in that direction, but I cannot quite disclose it. So maybe in keep following us, and maybe in a few weeks we will have something to say about that. That is one thing. And another thing is that, yeah, probably the best thing you can do is to try, again, if you have also good tests, try and build and see how the application is behaving, and that is probably the best way at the moment. Or you can check the info on your library if that is, saying in any way that it's compatible with native image and it's providing all the necessary information.
Okay, but the libraries itself don't come out with a Graal compliant approval badge, something that say this library. Is there something about around the people?
So that is a good idea.
Yeah.
That is all I can say at this moment.
You can submit a PR.
Yeah. That is one thing you can do, yeah.
What I usually do for esoteric libraries that I would.
I like that you're saying esoteric libraries and pointing at me. No, I'm kidding. But also, I think I'm staying around if we are not wrapping up yet. So if you would rather just ask a question like this, I think that should also be an option.
So if you are following this from the... se state seguendo dal canale YouTube potete continuare a fare domande, cerco di riportarle allo speaker come sempre. Ci sono altre domande dal pubblico? A questo punto direi che, vabbè, allora mi spiace ma purtroppo per gli amici da casa noi siamo gentilmente anche offerti di pizza e birra, mi spiace per chi diciamo virtualmente, quando avremo il metaverso magari riusciremo a fare questa cosa, so thank you very much.
Thank you for having me.
So before you leave your seat, just a couple of logistic questions. I sent in the mailing list the form for the raffle. So as usual, we thank JetBrains for having the opportunity of one raffle for an IntelliJ idea or whichever product you prefer license. So you will find in the mailing list the form to do it. Then shall we? Ok. Per chi volete potete rimanere qua per diciamo un rinfresco, un aperitivo, o comunque anche chi di solito poi c'è sempre un gruppo di persone che magari prosegue la serata. Se volete facciamo una foto, visto che è il primo meeting del 2023, state seduti ai vostri posti. Per chi non vuole essere nella foto vi mettete la mano davanti alla faccia che fa da censura, diciamo. Together.
How do you want to do it?
Yeah, just do 360 and then maybe we can
Oh, wow. Okay, that's fine.
così almeno abbiamo anche un'idea alla gente a casa.
Perché levi la camera?
No. Ok.
Spegni troppi soldi sono.
Vediamo che manca qualcuno. Aspetta, vogliamo accendere la luce qua?
Sì.
Questa?
Accende qua.
Oh, aspetta. Pronti a fare i cheese in 3, 2, 1. Sì? Vediamo se ci riesco anche col triangolare. Cioè, scusate, il grandangolare.
Yeah?
A big picture of you. Chi è che mi manca?
La palla lì tranquilla.
Tu
manchi.
Luca un po' più in dentro, tu? Ok, cheese in 3, 2, 1, one more. Ok, great. Thank you so much.
Globo, cioè stare qua, andare di là nella cantina, come volete.